Hello students, we are beginning the last lesson in Unit 3. It's called Finding All the Zeros. What it really is factoring, going from standard form to intercept form. See, and if you're asked to find the zeros or to find the roots, what you do is you set that up equal to 0 and then you solve for x. So in this case you would have one root and that would be at 1. If you have a trinomial such as this quadratic function here, then if you remember, if your a value is 1, it's usually kind of easy to do this. Sometimes you can't do it this way, but what you do is you look for a number that when you multiply it, you get negative 15, or two numbers, I'm sorry, a pair of numbers. When you multiply, you get negative 15, and when you add them or combine them, you get negative 2. If the a value is not 1, then you have to split the middle term and then group. And I'm not going to do one like that in this lesson, but you can go back and review that in the factoring trinomials lesson. So a number that when I multiply I get negative 15, and when I combine them I get negative 2. Well, of course we're going to use 3 and 5, and we need to use a positive 3 and a negative 5 to get negative 2. So the factors are going to be x plus 3 and x minus 5. So then we set both of those up equal to 0 and then solve for x. So our roots are at negative 3 and positive 5. Okay, so that is the extent of our review here. We're going to move on to sum and difference of cubes. So if you have two numbers and they're added together or they're subtracted, and each of them is a perfect cube, then you can factor it by using this formula. I'm going to give you the formula first, and then we're going to actually do some examples. What you end up with is a binomial and a trinomial, and sometimes that trinomial can be factored. If it can't, we have to use quadratic formula. Okay, so if you have a cubed plus b cubed, and these are numbers. Now one of them could be a variable, but if you have a cubed plus b cubed, what you have to figure out first is what a is and what b is, and you take the cube root of each of those numbers. So you find a and you find b, and then this is the formula that you follow. You have a binomial a plus b, and then your trinomial is a squared minus a times b plus b squared. Okay, and these two formulas look very similar. You just, this minus goes in two different places in the formula. So if you have the two numbers added together. If you have them subtracted, then your binomial becomes a minus b. Your trinomial is a squared plus a times b plus b squared. Okay, so just keep these in mind and understand that the first thing you want to do is identify what a is and what b is, because there'll be numbers. This might be a 64 or a 729 or whatever, and you have to take the cube root of that and find out what a and b are before you can put them into this formula. So a lot of this is just recognizing what you've been given and being able to say, oh, that's two cubes. That's two perfect cubes right there. So this is an example of the sum of two cubes. X cubed is a perfect cube because any variable to the third power is going to be a perfect cube. 64 is also a perfect cube. This is 4 cubed. So let's identify our a value is our x. It's just x to the first power. And then our b value is the cube root of 64, which is 4. And if you're not sure, I'll show you on your graphing calculator. Of course, you can just take the cube root. I also wanted to show you though, sometimes it's easier to use a fraction exponent. So if you were to enter 64 and then your caret button, your exponent button, and then 1 divided by 3, if you enter it like that instead of trying to do the cube root, because on these calculators it can be a little bit of a pain because I think you have to go to the math button. So if you just enter 64 to the 1/3 power, that will give you the cube root. So anything to the 1/3 power, that's the cube root of that number. Okay, so a equals x, b equals 4. So if we follow our formula, which I'm going to write up here again. Okay, so a plus b is my binomial. So x plus 4. A plus b is x plus 4. And then my trinomial is going to be a squared, which is x squared, minus a times b, which is 4x, and then plus b squared, which is 16. Okay, so now what I have is I have one factor that I can set up equal to 0. X plus 4 equals 0. X equals -4. So this is one of my roots. But I need to find the other two roots, because you see I have a 2 here, so I have 2 more roots that I need to find. And looking at this, there's no way I can't put this into 2 binomials. There's not a number that multiplies to 16 that will, 2 numbers that multiply to 16 that combine to give me -4. So I have to use quadratic formula. Now I'm going to set that up and come back. Okay, so what I did here is with these trinomials where we have to use quadratic formula, we have an a term, a b term, and a c term. So a equals 1, b equals -4, and c equals 16. And then here's your quadratic formula. You should have learned that in math too. I know y'all did the little song. So let's set this up. All right, so the opposite of b, which is the opposite of -4, plus or minus square root -4 squared. And then that's minus 4 times a times c. And all that's under that radical. And all of that is over 2 times 1. Okay, so let's start simplifying this. The opposite of -4 is 4, plus or minus square root. This is 16. And minus, that's going to be 64. So this is 16 minus 64, which is -48. And all of that's over 2. I'm going to continue over here, try to save myself a little bit of room. X equals 4 plus or minus. Now, if you remember, if we have a negative under the radical, we're going to pull out an I. We're also going to simplify this. This is 16 times 3. So let me go up here. This equals, I'm sorry, not absolute value, square root of -1 times square root of 16 times square root 3. So I can pull out an I here, a 4 here, and then leave that root 3. So I'm going to write that 4i root 3, and that's over 2. Now I'll show you a little trick. If you've got 3 terms that will all divide by the same number, you can simplify this. So I don't need to leave it like this. I can divide all of these by 2. And then I have 1 in my denominator. So my other x, or my other roots, are 4 plus 2i root 3. And you don't have to separate them if you don't want to. 4 minus 2i root 3. So remember, if you have one of those irrational or imaginary or complex roots or whatever, you're going to have 2 of them. And so there's my pair of complex roots right there, complex conjugates, 4 plus 2i root 3, 4 minus 2i root 3. So I'm not going to have time during this video to go through all of these, but I can make a second video and get the rest, the ones that I skip over. I do want to look at this one though. This is number 2 in your notes. And I want you to notice these are 2 perfect cubes. 8x cubed is a perfect cube, and so is 1,000. But this has a GCF that we can pull out first. The GCF of these 2 numbers is 8. So if we pull out an 8 here, then we can factor this to 8 times x cubed plus, what is it? 125, yeah, sorry, 125. And 125 is 5 cubed. So then we really don't need the 8 anymore, honestly, but we can use our sum of 2 cubes to write this as x plus 5. And then x squared, I'm sorry, I'm getting ahead of myself. A equals x and b equals 5 in this case. So this is for this binomial right here. So x squared minus 5x plus, and then 5 squared is 25 if we're using our formula. All right, so one of my roots is x equals -5. So that's one of my solutions. Okay, so I need to now figure out if I can factor this into two binomials, and I can't. There's not two numbers that multiply to 25 that combine to -5, so I need to use quadratic formula again. And I'm not going to take all the time in this video to write everything with quadratic formula. I'm going to pause my recording and go ahead and put the quadratic formula over here. You can try it. You can pause your video and try it and then come back. Okay, so I filled in part of the quadratic formula and then I'm going to finish it down here. So opposite of -5 plus or minus square root of -5 squared minus, and then your 4ac, and that ended up being 25 minus 100, so that's -75. And over here I just showed where square root of -75 is square root of -1 times square root of 3 times square root of 25. So then I'm going to rewrite that as, that's going to be 5i root 3. And all that's over 2. And this is actually the answer. You could leave it like this, or you could take this and say, okay, this is x equals 5 plus 5i root 3 over 2. And x equals 5 minus. So all I'm doing is taking this plus and minus and separating them. So those are your complex conjugates again. So those are your three roots with your conjugate pair. Okay guys, so number 3 is very similar to number 1 in that the GCF is 1. So for this sum of two cubes, a was 4x, because this cube root of this is 4x, the cube root of 27 is 3. And so I set up the binomial and the trinomial here, and then I did 4x plus 3 is equal to 0 and got one of the x's is -3/4. And then I did quadratic formula over here. I highlighted this so you can see where the a value came from, the b value, and the c value, and then you can also see where they fit into the formula itself. I hope that helps. Also down here I got root -432, and this is where I got the simplification for that over here. And that was 12i root 3. So you can pause your video and copy this down if you'd like. Oh, and one last thing that I didn't talk about is right here, I got 12 plus or minus 12i root 3 over 16. All of these will divide by 4. So I divided all those by 4 and simplified it to 3 is on top and 4 in the denominator. So for number 4, I'm not going to bore you with quadratic formula and going through all that, but I do want you to recognize here that you need to look for the greatest common factor in every time you have to factor. Look for greatest common factor first, and then look at it again and see what you have. So if we look at this one in particular, we see that the greatest common factor here is x. So when we pull out an x, we have 8x cubed plus 1. And this is a sum of two cubes. So this would mean that x equals 0 is one of our roots, because we have x over here, so that's a factor right there. And then we would have to go from here and do the sum of two cubes. So let's look at that and let's talk about what the a value and b value are. The a value is going to be the cube root of 8x cubed, which is 2x. And then your b value is the cube root of 1, which is 1. So then when I do the binomial, I have 2x plus 1. And then the trinomial, if I can get a pen here, is going to be 2x, the whole thing squared. So that's 4x squared. This will be minus 2x times 1, which is 2x. And then plus 1 squared, which is 1. Okay, so then I have another factor that I can set up equal to 0. 2x plus 1 equals 0. Okay, so there's my second factor. And to find the third and fourth, which you can see right here, you've got a 2. So there's going to be 2 more. We are going to have to use quadratic formula again. And I'm going to pause the video and work all that out so you can see it. Okay, so as you look at number 4, again, we did GCF x. We got x equals 0, and then we did our binomial or trinomial. We got another x equals -1/2. And then over here, I did quadratic formula. The square root of -12, that was 2i root 3. And then at the end, I could divide all of these by 2, and then I separated them into plus and minus. You don't have to. You could have actually just put a box around this, and that would have been correct as well. So I'm not going to work completely through number 5, but I will tell you GCF here, you got to do GCF. If both numbers are even, you know they've at least got a GCF of 2, and they do have a GCF of 2, so then you would rewrite this as 2 times, and this is 27x cubed minus 1, difference of 2 cubes, where a equals 3x and b equals, that's going to be 1. Yeah. So then you can work this, you can finish working this out, and I'll go ahead and give you the answer to this one. Let's see. So we have one of the roots is x equals 1/3, and then the other one, and I'll just leave the plus and minus together. After you do quadratic formula, you would get -1 plus or minus I root 3 over 6. So this is one root, and this is your pair of conjugate roots for that one. Okay, so this one I'm not going to work all the way through as well, but I want you to recognize this is a difference of 2 cubes. A equals x, and b is the cube root of 729, which is 9. And then the way you're going to do this is you're going to do x minus 9 this time, because remember, if it's difference of 2 cubes, you got a minus here, and then you've got 2 pluses in your trinomial. So this is going to be x squared minus, plus 9x plus, and then 9 squared is 81. Okay, so this is sort of a summary of number 6, quadratic formula. This is your A, B, and C, and then this is your conjugate pair right here. So you had x equals 9, and then this one here. So now to the last section of our notes. This says find all the zeros for cubic and higher polynomials with middle terms. So these are not sum or difference of cubes. These are polynomials that have middle terms. And so let's look at some of these. I do want to fill in right here. Use synthetic division, which we've learned, to break down the polynomial into a quadratic. And then that will help us find all the zeros in a polynomial. So your first one, number 7, let me make sure I got this right. Yep. It says find all the zeros, and then it gives you this polynomial, which is cubic. It has a 3, so we know that it has 3 zeros. And then it tells you x minus 8 is a factor. So if x minus 8 is a factor, that means there is a root at positive 8. So I can use synthetic division here to find the quadratic equation, or excuse me, the quadratic expression when I take out the 8. So let's use synthetic division. I'm going to put our 8 here, and then we'll have coefficients of 1, -4, -29, and then -24. And when we do this, we should have a remainder of 0 because we've been given the fact that x minus 8 is a factor. So let's bring down our 1. That's going to be 8, 4, that's 32, so that's 3. 8 times 3 is 24. So when I combine those, I get 0. This is my remainder. This is my constant term, my x term, and my x squared term. So now what I have is, first of all, I'm just going to write this. X minus 8 was a factor, okay? And then when I divide by x minus 8, I get x squared plus 4x plus 3. So I have one factor, so I can find one root, which I already did up here. X minus 8 equals 0, x equals 8. So this is one of my roots, x equals 8. Now, I have a trinomial here, and finally I have one that I can actually factor into 2 binomials. This is going to be x plus 3 and x plus 1. It actually does factor that way. And so now I can set those two up equal to 0 and get my other 2 factors. And that's all I have to do with that one. So if you can factor this, that's awesome. You don't have to use quadratic formula. If you find that you can't factor it, then you use quadratic formula. Okay, so we have 2 more problems, and obviously I'm going over 20 minutes, but I do want to cover all of this. So this one says, find the zeros for this polynomial if -3 is a root. So we haven't been given the factor, so we are actually going to use the -3 and do some synthetic division. Our coefficients are 8, 24, -27, and, oh wait, nope, I have a 0, don't I? I have a placeholder because I don't have an x squared term. So I have a 0 and then a negative 27 and negative 81. So my remainder is 0, like it should be, because they told me negative 3 is a root. And then I don't have an x squared or an x term. So this is going to be 8x cubed minus 27, which is a difference of 2 cubes. My factors, when I do this, are going to be 2x minus 9, no, I'm sorry, minus 3. And then 4x squared plus 6x plus 9. Okay, and then I'm going to give you the answer to this one because, first of all, we would set this up equal to 0. We already know negative 3 is 1 0. We should have 4 zeros total. So negative 3 is one of them. So x equals negative 3. That's 1. If I set this up equal to 0 and solve for x, I would get x equals negative 3/2. So that's another one. And then I would have to use quadratic formula to do this one. So I'm just going to give you the answer to this one. X is going to equal negative 3 plus or minus 3i root 3 over 8. Did we not just do something similar to that one? I think we did. Okay, so I do want to look at this last one together. There's no quadratic formula in it, which makes it really nice. I see that I have a 4th degree polynomial, so that means there are 4 roots. And I've been given one of them. So one of the roots is x equals 1. I can use synthetic division to figure out the polynomial that I get when I divide this by x equals 1. So I'm going to do that and then come back. Okay, so I did my synthetic division. My remainder was 0, which it should be. This is my constant. This is my x term, my x squared, and my x cubed. So I have x cubed minus x squared plus 9x minus 9. So this is what we get when we divide this polynomial by the x equals 1. My key does this another way, but what I'm seeing is I've got 4 terms here, so I'm going to use grouping. If you remember, we did that when we split the middle term on our trinomials. So we ended up with 4 terms, and we were able to group those. So let's group these like this. And what I'm going to do is I'm going to pull out the GCF. So the GCF of x cubed and x squared is x squared. And then I have x minus 1 in parentheses. If I pull out a 9 here, I have x minus 1 in parentheses. Whoops, didn't put my 9 there. And so if you remember, what we did was we just made sure that this and this matched, and we said, okay, we can take that out. That's the greatest common factor. So that is one of the factors. If I can get this pen to come back up. There we go. So one of the factors is x minus 1, and the other one is x squared plus 9. I can set this up equal to 0 and find my other 2. So this is x minus 1, which means I have another factor at x equals 1. So that's your multiplicity. So you would have this in your factored form, in your intercept form. But, I mean, we don't need to know that. We just know that x equals 1 shows up twice, okay? So, so it bounces there. My other one, x squared plus 9, if I set that up equal to 0, I can take the square root of both sides and get x equals, and then this is going to be plus or minus, because, you know, it's a square root, so it's going to be plus or minus 3i. So another root is positive 3i. And of course, if I have a 3i, I have to have a negative 3i. So there are my 4 roots right there. And one of them can show up twice. Remember, if there's a bounce there or whatever, then it can show up in an even number of times. So I'm going to see if I can find an IXL that would go along with this lesson, and I'm going to drop a link in the comments. Or, no, I'll drop it in the description if I'm able to. So let me know if you have any questions or comments. Thanks.